Okay, we're going to have a look at Napiers rules now for what has now become a right-angled spherical triangle. So in the previous great circle problems we were simply looking at a situation where we had a spherical triangle. Now we have right-angled spherical triangles because we've introduced now the vertex, the point of maximum latitude. PV is our maximum latitude. And the two basic formulas that you need to remember: sine midpart equals tangent of adjacent parts, and I've put in red there the two A's to remind you if it's tangent it's adjacent, and sine midpart is cosine of opposite parts. So again, two O's, cos becomes opposite, and we both start off with sine, so it's sine midpart equals either tangent of adjacent or cosine of opposite. So just remember tan, sine, tan, cos, tan is adjacent, cos is opposite. They're the only three values you've got: cosine, tangent, sine. So the first one is sine, tan adjacent, cos opposite. And if we look at a diagram there, that's PA, of course, which is 90 degrees plus or minus latitude, PB 90 degrees plus or minus latitude, PV is 90 degrees minus the maximum latitude. So we know that value there, we know that value there, and we know that value there. We know those three values. So if we draw the wheel for Napiers rules, there's the wheel there, and we've got PV, VA, P, PA and A. And I've circled the known values. Okay, so we know those two values. And if we wanted to find the A, the initial course, which is this one here, then what we have to do, we have to say, okay, we know that one, we know that one, we don't know that one, so we need to involve those three in the formula. And we can see that sine the mid part excuse me, equals cosine the opposite parts. So in this instance, PV is the mid part and PA and A are the opposite parts. If we had the values P and VA, they would be the adjacent parts to PV. But PV, these two are opposite, so they're the four values we would use. And incidentally, when you're using Napiers rules, always use the two values that you know, because if you use a value that you've calculated and you've made an error, of course everything else gets thrown out. So always use the values that you know. So to find the initial course, we'd use those two, and we'd say that sine PV, and now it's cos co PA and cos co A, because they're below the wheel, of course. So sine PV, because it's cos co both those, they would convert to sine PA times sine A, and we want to find sine A, so sine A would be the sine PV divided by sine of PA. It would be useful to get used to doing this mathematical changing of the formula to get your confidence going with Napiers rules. When we're solving the final course B, what I've done now, I've changed VA to VB, and I've changed PA to PB, and of course A to B. It's the wheel's exactly the same, but I've just put now my two known values as PV, of course, and PB. And we're looking for B, which is the final course. So we're doing the same thing here. These are the two that are involved, plus this one. So this is our mid part, and these two are our opposite parts. So it's exactly the same as we did initially to find our final course. So using the wheel, if it was this value, those two would be opposite, those two opposite there. Okay. Now, if we're trying to find the distance A to V, okay, A to V, then these are the two values that we know. A to V is what we're trying to find. So in this instance, we'll use PA as the mid part, and these two are opposite parts. So I hope you can see that. We know these two values, we're trying to find that one. So PA becomes the mid part, and of course that's sine co now because it's below the wheel, and these would simply be cosine PV and cosine VA. And you would simply, doing as I've done there, change the formula around, and you get cosine VA is cos PA over cosine PV. Then we look at finding the D long P, which is in effect APV. Okay, so we're looking for P. So that's this value here, P, and we know PV and we know PA. Okay, so in this instance they're adjacent. So in all the previous ones they've been opposite, but this one now, P is adjacent to these, so it's tangent. We're going to use tangent now. Now that's going to be sine co P is equal to tangent of PV times cotangent or tan co of PA. And again we'd have to move the values around. Sine co P becomes cosine P. Tan PV times 1 over tan PA. Therefore cosine P is tan PV over tan PA. And we do exactly the same to find the distance BV and the d long B PV, just as I've done there now, by using the second wheel that I've drawn. Everyone has different ways of solving these problems, of approaching them, I guess, really. We all have the way we find is a useful way. I find drawing the wheel, two different Napiers wheels, I find it easy to do it that way because I've changed the values from A to B, and then when I look at them mathematically I can see what I should do. But the important thing to remember is always use the two values that you know. Always use those to find the third value, because on the wheel, as long as you know two values, you can always use those to find the third value that you're looking for, regardless of which one it is. So whether you're looking for A, VA or P, by putting any of the two that you know with this third one, you can always solve the problem. So always use the two known values and you'll be able to solve using Napiers rules. But just remember, sine mid, it always starts off at sine mid equals tan adjacent cos opposite. Tan is A for adjacent, cosine opposite. And just get used to the wheel. Again, it's just practice looking at it and working out the relevant information.